Hello everyone, my name is Rehanto Aikanta. Now the topic is about the geometrical model of bounded region formed by curve and straight line employing double integral. Double integral over rectangular regions. In double integral over rectangular regions, we study the concept about double integral and examine the tools needed to compute them. We learn techniques and properties integrate functions to variable over rectangular regions. We also discussed several applications such as finding the volume bounded by a function over rectangular region, finding an area by integral, and calculating the average value of the function of two variables. In this section, we consider double integral of functions is defined over a general bounded region dd on the plane. Most of the previous results need to be extended cover this general case. General regions of integration. An example of a general region dd on a plane is shown in the since dd is bounded on the plane, there must exist a rectangular region R on the same plane that encloses the region dd. That is, a rectangular region R exists such as dd is a subset of R, dr, R and R. For region dd that is subset of Rr, we can define function of g of x comma y2 equal to f of x comma y at every point d and 0 0 at every point of R not in dd. Suppose z is equal to f of x comma y and z is equal to f of x comma y is defined on a general planar bounded region dd as in order to develop double integrals of over dd, we extend the definition of the function to include all points on the rectangular R region RR, then use the concept tools from the preceding section. But how to extend the definition of the include all points RR? We do this defining a function g of x comma y on RR as follows. G of x comma y, f of x comma y of x comma y is differentiate x comma y is a R but not in dg of x comma y is equals to f of x comma y if x comma y is dO if 2 if x comma y is in R but not in D. Note that we might have some technical difficulties if the boundary of dd is complicated, so assume the boundary to be piecewise smooth and continuous simple closed curve. Also, since all the results developed in double integral or integral rectangular regions used an integrable function f of x comma y, we must be careful about g of x comma y and verify that g of x comma y is an integrable function over the rectangular region R. This happens as long as the region dd is bounded by simple closed curves. For now, we will concentrate on the description of regions rather than function and extend our theory appropriately for integration. We consider two types of planar bounded regions. The definition of general region of integral. Region dd in the x comma y plane is a type of I if it lies between two vertical lines on the graphs of two continuous functions g1 of x, g1 of and g2 of x, that is d of x comma y a less than x less than b g1 x less than y less than g2 x d is equals to x comma y. Region dd is a xy plane is of type 2 if it lies between two horizontal lines on the graphs of two continuous functions h1 of y and h2 of y, h1 of y and h2 of y, that is d of x comma y by c less than y less than d h1 of y less than x less than h2 of y. These are the curves of geometrical model of bounded region. These are the curves of double integral over general region. This is the example of general bounded region, x-axis and y-axis. Thanks for watching.